Hello, everybody. Welcome to week 4. It's hard to imagine how fast the semester is going, but that's always the way it goes. So, anyhow, welcome to week 4. So, for this week, come on, let's go a little further. Oh, come on. Okay, so announcements. Not much in terms of announcements. Remember to work on those PAs and CAs and get everything right. You should get hundreds. In those Xylabs, the same thing. You had a whole bunch of them last week, and this week we don't have so many, but get used to working with those. We've got a bunch of them to go through. Group project, we talked about this before, and I'm going to keep bringing it up just because I want you to start thinking about both whatever teams you want to work with, if you can, get in touch with some people in the class and read some of their intros and things, and then start looking at some of those data sets. Now, I did the identity verification with a whole bunch of you this week, and one of the things I talked about along with who you are and matching your photo from high school up with your current image on Zoom was to ask about what kind of things are interesting to you in terms of the group project. Now, the best kind of a project that you can have is one that is A, interesting to you, and B, gets you started in a direction that you might want your career to start off in. So if you're interested in health information or genomics information or biological information, look for some of the data sets out there in BigQuery that deal with that because they're there. There's no doubt about it. There's tons of them. I wouldn't know what to do with genomic information from a data set, but maybe you do. And so, that might be something that's really interesting to you. If you're more interested in business oriented things, marketing studies are always really good to do using BigQuery information. And they're kind of cool. I'll post some more things as we go. Some of the projects that I used when I did ISTE, not 608, what was it? The visual analytics course. I thought they were kind of fun. There was one that looked at providing the rationale for a large real estate investment in Chicago. And the reason that we use the BigQuery for this is that, Chicago's got this rap of being a dangerous place, the number of shootings and, all that kind of stuff. But my question was, is it true? It seems like people live in Chicago, so there's got to be a way to get by in Chicago without getting shot. And so the way I formulated the question was I said, here's a big real estate company is looking to you for advice on which of the political regions to invest in Chicago. And in Chicago, they're called wards, WARDS. And each ward it has a representative, and we can, in our data set, in the Chicago crime data set, we can see crimes by ward. Well, that just made it interesting. And so I said, with the investment group that you represent is concerned about the culture of lawlessness in Chicago. Well, there's lots of crimes in there in the Chicago crime data set, but which ones represent a crime that would impact on people's perception of a culture of lawlessness? If there was a culture of lawlessness in a neighborhood, you probably wouldn't want to live there. But if there's crime, but it doesn't promote a culture of lawlessness, maybe it would be okay. So it was a really interesting project, and none of the groups that worked on this project came up with the same wards to recommend. And that was the best part because it really got the students to think about How do I define what a culture of lawlessness is? If there's always a financial trade-off about, if you live right downtown, that's great, but it's really expensive. If you live a little bit further out, that's going to be cheaper, but you've got commuting issues to deal with too. So all of those things had to be worked into the wards that they recommended investing in, and including things like who are the politicians that represent the ward. And so the students had to go find these ward representatives and look at their web pages and find out information. It was a great project. I loved it. I think the students thought it was a lot of work. It sounded easy, but it was a lot of work. But it was also lots of fun too, because they really got to dig in. And I think there was one person who knew anything about Chicago. The rest of us just had maps and drawings and data to tell us what we needed to know to make a recommendation. So that would be a totally cool project, and for this class, and so we'll talk about that some more as we go. Anyhow, resources to learn about BigQuery. Remember, there's a lot of things out there. You're going to have to figure these things out and get used to working with BigQuery to figure out what's interesting and what's not. Let's see. So this week we're in the Xi Lab. We're in week 4. In week 3, we talked about some of the basics of SQL and just looking at things that you do. Different query languages and selecting, inserting, updating, deleting. And that's the neat thing about SQL is that there is this very small number of operations that you really need to do. But with that small number of operations, you can get a lot of things done. And so, that's why I find SQL to be so really interesting. A lot of times you run into this. There's 4 things that you can do: insert, update, delete, and there's another one. Select. And that's it. And so, that's pretty cool stuff. And then the managing of databases, that's interesting too, mostly because you have to know how to do it. This is really part of the DDL, the data description language. Anyhow, there's 3 different languages. You have 3 different languages that make up SQL, and this is one of them. But first off, you have to create a database. You have to decide which database to use, and you create tables inside the database. I love these show commands. Don't forget your show commands. They're so useful when it comes to troubleshooting things that don't work. And, most things don't work when you first do it. So it's good to know your show commands. Yeah, that was last week. This week, we're going to be doing a little bit more advanced things in SQL, but they're still, pretty basics. And we're really thinking about data types here to a certain degree. Let me bring this back. And so first off, we're going to talk about different data types. And we have 2 different kinds. 1, 2. Welcome to SQL. We've got the simple, kind of well-known ones, the ones that have been around forever, integer, decimal, character, those kind of things, those data types. And then we've got the complex, which are kind of the not so well-known data types. And those are documents and spatial data and object data types. All of those things are different and require a much more complex data structure to store that information. Your data type is all about data structure. How many bits do we need to allocate for each one of the fields in a table? That's part of what database management systems do. We don't have to do it because this is an abstracted language. A lot of things are hidden under the covers. and that's good. But on the other hand, we've got to supply the database management system with the information that it needs to allocate resources to store the data that we want to store. And that's where these data types come in. Now, the simple ones, those are really the old style ones, the ones that handle most, vast majority of, it's probably too much to say now. Let's stick with most. Business data, of the traditional relational database kind of things. The complex ones are kind of more modern, where before we just didn't have that much semi-structured or unstructured data. We just didn't do it. And we certainly didn't store it in the database. But now we do, because we have so much semi and unstructured data. Unstructured would be things like images and audio files and PowerPoint files and Word documents. All of those things are different, and some are huge, some are small. Well, how do you allocate space for that in the database management system? That's complicated. Let alone spatial information, where you have geometric or geographic information, and then object-based data. These are complicated, more modern things that we need to keep track of, and there's tons of them. And a lot of times, these are the place where you might store these might be out in the cloud, where you may have data blobs and just really unstructured, completely unstructured data that you want to either link to or store in a database, and that's a complicated thing for the database management system to do. Now, the one thing that this chapter talks about is the thing that makes databases useful. That's a big statement, but I'm standing behind it. Without transactions, databases would be useless. It would just be a toy. Transactions are everywhere in business databases, where we don't want to change something until we make sure that something else that's related to it changes first, or in synchronous with, or whatever. And that's where transactions come through. So a transaction is a sequence of database operations that must either be completely completed, or rejected completely. We never want to have partial execution of a transaction, because that's going to end up with the worst of all possible scenarios. The classic transaction is you want to pay your buddy, you had a sports bet, and you want to pay off the bet, so you want to transfer money, the $100 from your savings account to their savings account, right? So half of the query that needs to run is going to be, first we open up your account, we subtract $100 from your account, and then we open up your buddy's account and we take that $100 from your account and add it to their account. Well, that's two separate queries. And the worst thing that could happen would be that we subtract the money from your account, and then the system dies and the money's never allocated to your buddy's account. So your buddy says, "Hey, I thought you were going to pay me," and you say, "Well, I did. Look, there's $100 out of my account." And he says, "Where's the money coming into my account?" That needs to be a transaction. So if the system crashes halfway through, what we want to do is we want to roll everything back to the beginning. If we can't take the money from your account because maybe you don't have an account, you just lied and told your buddy that you had an account, but in fact you don't, or maybe you don't have $100 in your account, or maybe your buddy's account does not exist. I mean, that can happen. There's sausage fingers operation on typing in the account number, or whatever it may be, or whatever. The system can crash halfway through. Anything that can happen that can make the system fail halfway through the completion of that 2-query sequence. That's the problem. So transactions make databases useful. Uh, um, Saving a complete transaction results in a database is called a commit. Where we reject an incomplete transaction is called a rollback. A rollback reverses the transaction and resets the data to initial values. So you can see where this can be pretty complicated, because when you run that first query, it doesn't just subtract the money from your account. It needs to first ask, is this account available? Yes. Is there $100 in this account? Yes. Can we take the money from this account and put it in some? Is the money ready to be withdrawn from this account? I'm going to rephrase that a little bit. Then you go to your buddy's account. Does the account exist? Is the account ready to accept a deposit into it? And then we have to have both sides of the transactions ready to go. And then they both sides of the transaction kind of go 1, 2, 3, go, and the money changes hands. But if it fails halfway through, then we've got to say, wait, roll back. Everybody go back. Don't credit $100 to your buddy's account, and don't subtract $100 from my account. So that's a complicated series of things that have happened. But it's the essence of business computing. And so transactions are complicated as they may be. They're pretty straightforward to do in SQL and MySQL. And they're the basis for databases being useful for business. And so that's a really important concept. Now, another thing that we're talking about in this chapter is this idea of how do we make databases that are useful for business. And one way that we can think about this is that any database that's useful for doing business lives up to what are called ACID properties. So atomic, consistent, isolated, and durable. That's what ACID stands for. 4 things. Remember, such much 4 things. So if you think about what the properties of a database that's useful for business computing are, these are some of the properties that they have to live up to. Every transaction needs to be atomic. Either all or none of the operations executed. So it has to be able to do real transactions. It needs to be consistent. All rules governing data are valid when the transaction is committed. Completed transactions that violate any rules are rolled back. Consistency. So we have rules around what data types we can work with, what fields we can work with, who has access permissions. All of these kind of rules that govern the data in a database need to be in place before we can use it. And then an isolated transaction is processed without interference from any other transactions. And that makes a big difference, because these are transactional databases that we're talking about. That's the common way to describe a business database. And when you think about a bank or insurance company or investment firm, they have hundreds of thousands of transactions going on at any given time. Well, what isolated means is that each one of those transactions is isolated from all the other transactions. It doesn't matter what's going on with other transactions when you start thinking about how do we make this transaction work. Then the example that they use in the iBooks is a really good one, because it gets at how big these databases are. Things don't just happen and are done. It takes time. So they walk you through a scenario where you have somebody who is giving somebody a pay raise, summing pay, how much people get paid or something like that. And then they also say, we want to go through and give everyone a pay raise of 10%. Well, what that's getting at is it's getting at that same field. We're going to go through each one of our employees' rate of pay field, the attribute that's associated with how much money they get, and then we're going to raise that by 10%. Well, that doesn't happen just like that. It happens slowly over time. We've got to go through each one of those records, open the record, find the field that we want, then multiply that field by 1.10, and then restore that information back into that field again. That takes time. At the same time, we want to do this other transaction that gathers information based on the rate of pay. Well, what should happen is that only one of those things can happen at any given time. You can't halfway through giving everybody a pay raise, come in and access those pay numbers halfway through, because then we don't know if that's the result, the pay rate before or after the pay raise. And it's those kind of things that this isolated thing really gets at. And that's that we got to make sure that there's no interference from other transactions happening during the time when we're working on something. Then the last one is durable. A transaction is permanently saved in the database once it's committed, regardless of system failures. So system failures happen. And since this is such old technology, the failures were more common back in the old days. And yet, even with those same potential for failures, to have a database be useful, it needs to be able to live with those failures and provide accurate information in the face of the database failing periodically. And so when we when we run the commit command after a transaction is processed, that means a lot. It means that we're telling the database that it needs to write this thing out to its storage environment and make sure that that write actually happens before we can say that this transaction is actually complete. And that's why transactions are so important in anything related to business computing. Now, to make all this stuff really useful, we've got these old ideas of system recovery. If we know that our database is going to fail periodically, then that means we need to be ready to recover it at any given moment. Well, how do you do this? Especially given how important this business data really is. And that's by the way it happens is by having this recovery log. So not only do changes get made to the database, but log files are created of everything that happens in that database while that thing is going on. And that recovery log is written to a separate location. It's organized differently. It's set up differently, but it's built with recovery in mind. How can we look at a separate location where all the transactions, all the changes, everything that happens in the database are stored so that when the system fails halfway through, we can go back and recover all of that information so we can rebuild our database. And we think about that from the get-go. We're always planning on the system failing because that's how important this data is. All right. Well, have a good week, everybody. And we've got about 2 weeks until your midterm exam, which I think I have on here. No. And I got the announcements page. Nope, I did not. Oh, you don't know. That's right. You don't have your midterm exam. You don't have a midterm exam. So nothing to worry about there. And anyhow, have a good week. And I will talk to you again next week. Take care, everybody. Bye-bye.